Okay guys, I'm trying to get y'all a video going here. This is adding and subtracting polynomials or dealing with polynomials, combining polynomials. So that says how many quarters, nickels, and pennies are needed to make $1.13? Well, we're going to need 4 quarters, 3 nickels, and 3 pennies, right? Dollar. Oh, nope, that's not right. Like 2 nickels. $1, $1.10, $1.13. Now, fill in the blanks here. For 8,943, what do we need? We need 8,000s, 900s, 4 10s, and 3 1s. We add all that together, we get 8,943. Or we could have 8 times 10 to the third, 9 times 10 squared, because we need 900, 4 times 10, and 3 times 1 still. Okay, now what does that do? How does that help us at all? Well, now we can combine these into times 20 to the third. What would we need? This would be something probably needed some refresher on because we're talking about cubes here. Okay, so 2 cubed is 8. So this is actually equal to 8,000. So we only need one of those. Now 20 cubed is actually going to be 400s. Okay, so we're only going to need how many of those? 20 times 20 is 400, so we actually need 2 of those. And then we have 20s, so right now we're up to 8,800. 20s, we're going to need 140 basically to get up to what we need, and then times 3. Just different ways of writing about this. So here we go. What's 5 squared is 25. So how many 25s do we need? We need 4 of those. So we're up to 100. Then we need 2 5s, and then we need 3 1s. Notice here and here are the same thing. Okay. Now let's be as general as possible by identifying which base we're in. Just call the base x. Okay, consider the expression 1 times x cubed plus 2 times x cubed plus 7x or times x plus 3 times 1. Or equivalently, x cubed plus 2x squared plus 7x plus 3. Now, what would be the value if we plug in 10 for x? So what's 10 to the third? Well, 10 times 10 is 100, times 10 is 1,000, plus, what's 2 times 10? Or we would say 10 squared first, so 100. 100 times 2 is 200, plus 70 plus 3. So that would equal 1,273. What if we plugged in a 20? Once again, for right here, what is 20 cubed? Remember, that is going to be 20 times 20, which is 400, times 20 more, that's going to be 1,000. And then we have 20 squared, which is 400, times 2 is 800. 7 times 20 is 140. And then plus 3. Hopefully, y'all followed with that because we said 20 cubed plus 2 times 20 squared plus 7 times 20 plus 3, and that would equal 8,943. Same thing here. That was the same as those numbers on the front too. Okay. What else do we have? When writing numbers in the base of 10, we only allow coefficients of 0 through 9. Okay. That's kind of like the scientific notation property. It only goes 0 through 9. Now, the question is, why do we do that? All right, let me try and make sense of that. So if we say we're using bases of 10, right? And I got, let's say if I have 11. I'm going to break that down and say divide by 10. And so I've got 1 10 and 1 left over. Right? So if I go from 0 to 9, if I go up to 10, I'm just having to add another 1 to my exponent. Okay? If I multiply up again by 10 again, well, that's 10 times 10 again. So that's going to be 10 to the third. So every time you go with a coefficient above 9, so to 10, you're going to automatically going to throw up another exponent because we're using bases of 10. Okay, so what's the value of 20x plus 3 when x is equal to 5? Well, we just plug that in, right? 22 times 5 plus 3. Well, 20 times 5 is 100, and if 5 times 10 is 110, plus 3 is 113. Now, how much money is 22 nickels and 3 pennies? Well, that's saying the same thing. 25 times 5, which is the nickels, and 3 pennies. So plus 3 ones. Now, that's not going to be 133, what? Not dollars, but cents. Or, this would be cents. It's supposed to be an E. Or it's also $1.13. Now, what number is represented by 4x squared plus 17x plus 2 if x is equal to? So all you have to do, plug this in. Plus 2. Well, this is 10 times 10 is 100, so that's going to be 400 plus 100, just throw our 0 on the end of that, plus 2. So that would be 572. Now, what is represented by 4x squared plus 17x plus 2 if x is a negative 2? So let's just do that. A negative 2 squares 4. So 4 times 4 is 16 plus, now 17 times a negative 2 is actually going to be a negative 34 plus 2. So 16 plus, this actually probably be easier going to combine these. That's negative 32. So 16 minus 32 is equal to negative 16. Okay. Now, if it's 2/3, well, I did not give myself room to write these. Let's go up here and do it. 4 times 2/3 squared plus 17 times 2/3. I do not like that. Plus 2. Okay. 2/3 squared is going to be 4 to the 4/9 plus 17 times 2 is 34. That's not divisible by 3. So times 2/3. Let's call it 11 1/3 plus 2. So that's 16 divided by 9, which is going to be 1 7/9, right? 1 7/9 plus 1 1/3 plus our 2 there. Don't like this at all. Let me see. So let's just go ahead and we get to add fractions. You got common denominators. It looks like 9. It's going to be our common denominator. So we have to say 9 times 1 is 9, plus 7 is 16 over 9. 3 times 1 is 3, plus 1 is 4/3. But we need a common denominator. So 4 times 3 is 12, plus 2. I got to have a common denominator. And just say plus 2. So that would be 18 over 9. So there's 30, there's 46 over 9. That's not. Let me see here. Okay, so I messed up through here. This should actually be, let's go back to right here. So this would be 4 times 4/9 plus 34 over 3 plus 2. And so we're going to need common denominators here. So let's go back, and what's 4 times 4 is 16 over 9 plus, well, this has got to be over 9. So we have to multiply 3 times 34 is 102. Okay. And then plus 18 over 9. Yeah, that's looking better. Okay. So that's 120 plus 16 is 136 over 9. Is that divisible by 9? No, because 1 plus 3 is 4, plus 6 is 10. 10 is not divisible by 3 or 9, so that doesn't work. All right, let's see here. What number is represented by? Okay, so that's just plugging those in on D there, or I'm sorry, on E. Let's see what else we got here. Let's look at these. We have how many hundreds? That'll be 4 hundreds, 110, 3 ones plus 2 hundreds plus 3 tens plus 1 1. And so that would equal, we'd have to combine our hundreds. So that's 700. Tens is 4 tens plus 4. So 744. Now, same thing here. We are just simply combining like terms. Okay, we're not multiplying these together, we're just combining like terms. So 6x squared, when we combine those, our x's are 4x plus 8. Now I need to check something right quick. Okay, yeah, we can leave it there. All right, so now we have to negate all those terms because of this negative here. So now we're subtracting all of those terms. So that's going to leave us with 2x cubed. And then we have a negative x squared minus a 5x squared. So that's negative 6x squared. We do not have anything to combine with our 4x. So that's just a negative 4x. And then 8 plus 7, because we have to negate that, is plus 15. Okay. So what I would do here is I would go ahead and distribute this. Distribute these first. So that'd be 3x cubed plus 24x minus 2x cubed minus 24. Combine these like terms here. And that leaves you with x cubed plus 24x plus, not plus, but minus 24. Okay, and same thing down here. Just combine like terms. So negative t squared plus t squared cancels and leave those alone at 0. Now 9t minus t would be 8t and then plus our 5. And that is it. Now